This is Algebra Lesson 10-2, Quadratic Functions Part 2. Essentially, this is all about quadratic inequalities. Graphing the quadratic inequality is similar to graphing linear inequalities. The curve is dashed when the inequality is a greater than or less than, and it's solid if it's a greater than or equal to or less than or equal to. And when you shade it, if the inequality contains the point y is greater than, then you shade above the boundary. And if the inequality contains y is less than or equal to, you shade below the boundary, much like you do test points when you give equations. All right, so let's look at this. Graph each quadratic inequality. The first thing I'm going to do to graph this inequality is I'm going to determine my axis of symmetry. That's the easiest thing for me to do, which is negative b over 2a, if you remember. So in this case, it's going to be negative 2 over 2 times 1, which is 2, which is negative 1. So my axis of symmetry is x equals negative 1, which means that my vertex, my x-axis, my x value for my vertex is negative 1. So now I'm going to find the y value of my vertex. To find the y value of my vertex, I'm just going to put in negative 1 for x. So I'm going to have negative 1 squared plus 2 times negative 1 minus 5. So this is going to be 1 minus 2 minus 5, which makes this minus 6. So the y value of my vertex is negative 6. So I now have my axis of symmetry, and I have my vertex. There's my axis of symmetry. Here's my vertex. Now I need some points. The easiest point, let x equal 0. Because if x is 0, y is the c term, which in this case is negative 5. Now I'm going to let x equal 2. And it doesn't matter. I can just choose whatever number I want. I could have chosen 1. I just chose 2 just because it was a random number. 2 squared is 4. Right, if I do that, 2 squared is 4 plus 2 times 2 minus 5. So I have 4 plus 4 minus 5. 8 minus 5 is 3. So 2, 3 is the second point on my graph. I can now plot all of these points after I draw my x and y axis in, obviously. So let's draw my x and y axis in. There's my x-axis. There's my y-axis. I'm going to plot the point negative 1, negative 6. And I think I'm going to graph in green. Negative 1, negative 6. 1, 2, 3, 4, 5, 6. That's this point here. My axis of symmetry is at the point of x equals negative 1. I'm going to label that. I don't want people to think that's my graph. Then I'm going to plot the point 0, negative 5. 0, 1, 2, 3, 4, 5 is here. It's 1 unit to the right of the axis of symmetry, so 1 unit to the left of the axis of symmetry is there. Plot the point 2, 3. That is 3 units to the right of the axis of symmetry. So we'll go 3 units to the left of the axis of symmetry. Since we have a greater than or equal to, it's a solid curve, so I'm just going to draw my curve in here, nice and neatly. Last thing I'm going to do is I'm going to test a point to see if it contains it or not. Okay, so because it says if y is greater, we're going to shade above it. If y is less than, we're going to shade below it. So if I'm going to test 0, 0, I have 0 is less than or equal to negative 5. 0 is not less than or equal to negative 5, so I am not going to shade where 0 is. So I'm going to shade where 0 is not, and in this case, 0 is not on the outside of my parabola, so this is where I would shade my parabola, on the outside. And last but not least, I should label my parabola. In this case, y is less than or equal to x squared plus 2x minus 5. Let's look at the second one here. Let's do y is greater than x squared plus x plus 1. Again, let's start with the axis of symmetry. And the axis of symmetry is negative b over 2a. In this case, it's negative 1 over 2. Okay, so my axis of symmetry is x equals negative 1/2. My vertex, we already know that the x value of my vertex is negative 1/2. I just now need to find the y value of my vertex. So that would be negative 1/2 squared plus 1/2 plus 1. Right, plus negative 1/2. I've done it twice now. Okay, so negative 1/2 squared is positive 1/4 plus negative 1/2 plus 1. Okay, so that's basically 1/4 minus 2/4 plus 1, which equals 3/4. So my y value is 3/4. So there's my vertex, there's my axis of symmetry. I need some points. If I chose the point 0, I would get 1 as another point. I'm going to choose point 1, just because I want to. 1 squared is 1, 1 plus 1 is 3. So there's my points. Now, it's a little hard to graph negative 1/2, positive 3/4, graphing by ones. So I think in this particular graph, I think I'm going to graph by halves, just because I think it might be easier to graph in the long run, and I want my vertex to be fairly accurate. And to do this, all we simply need to do is make sure we label. This is 1, there's 2, there's 3, half 1, half 2, half 3. There, now everybody knows I'm graphing by halves. At least I hope they do. First thing I'm going to graph is my vertex or my axis of symmetry. I'm going to do my axis of symmetry. My axis of symmetry is right here. That's negative 1/2. Now I'm going to graph my vertex. My vertex is negative 1/2, positive 3/4. Positive 3/4 would be about there. Then I'm going to graph the point 0, 1. 0, 1 is here. That is 1.1 unit to the right of the axis of symmetry, so I need to be 1 unit to the left. Then I need 1, 3. 1, 3 is here. That happens to be 3 units to the right of the axis of symmetry, so I go 3 units to the left of the axis of symmetry. It's a dashed line this time, not a solid line. Now I'm going to test 0, 0, because 0, 0 is not on my graph. If I test 0, 0, I get 0 is greater than 1. 0 is not greater than 1. So I'm not going to shade where 0, 0 is. If I'm not going to shade where 0, 0 is, that means I have to shade inside of my graph, inside of my parabola. So this is where I'm shading the B for this parabola. It's inside of it. And the last thing I need to do is make sure I label my graph. Remember, don't shade so close to your dashed lines that we can't tell your line is solid or dashed. I use a different color, so it's kind of obvious with me. But if you're using pencil, don't shade so close to your graph that we can't tell. And that's how you graph quadratic inequalities. Not really a whole lot more different than graphing linear inequalities, especially when it comes to shading the dashed line. You just have to remember to graph a few more points.